Hello and welcome to this Renew Economy webinar. It's the first webinar we've held and we're delighted to see such a good crowd joining us, and I think we've got a pretty interesting program for this next hour. My name is Giles Parkinson. I'm the editor of Renew Economy, and we have three very exciting guests today and an important subject: opportunities in high efficiency, bifacial and new solar designs. And I'll give a brief overview in a minute just to explain why that is important. Just a couple of housekeeping things. This session will be recorded and you will be able to download it later on the Renew Economy website. You may ask questions and we certainly invite you to do so, and you can do that through the Q&A button down the bottom. So just put that, and what we'll do is that we'll go through the presentations first. I'm only going to give a presentation of a couple of minutes. We've got our three speakers who will give a presentation of about 10 minutes each. And then we'll actually do the Q&A and we should be wrapped up by about 1 o'clock or whatever. So look, thanks once again for joining us. Look, I just want to give a brief overview of the Australian solar market. As you probably know, it has been a very strong market over the last couple of years. Just in the rooftop solar market, it's been incredibly impressive. We've got to 12 gigawatts in the forecast that will double or treble over the next few years. In the large scale solar market, we've got to about 5 gigawatts, depending on how you measure, fully commissioned or in construction or in the pipeline. And that's equally exciting. And one of the interesting things is what happens from here. And I think whichever way you cut it, the Australian solar market is going to grow significantly over the next 5 to 10 years. There is actually a plan beyond the politics that we see in this country, which for many people is very frustrating. There was actually a plan being put together by the Australian Energy Market Operator. It's called the Integrated System Plan. And it points to several different scenarios. And it goes from 90% renewables by 2040, achieving 80% reduction in emissions, which is really what we're all trying to do. 90% under the step change scenario, which is where we actually focus on climate change policies. And you may well think, well, what if we don't? Well, Australia is a unique situation. Apart from having fantastic wind and solar resources, it also has an aging coal fleet. And no matter what happens, this needs to be replaced. So even in its central scenario, AEMO forecast that renewables, that's wind and solar, will account for about at least 70% of Australia's generation by 2040. And that is an extraordinary opportunity for the renewable energy industry. It's an extraordinary opportunity for the solar industry. And it means, of course, that the solar industry has got to get things right. And we like to know about improved efficiencies and falling costs and all the other different possibilities and new technologies. And that's one of the reasons why we're holding this webinar now, sponsored by Longi Solar. And we do thank them for their sponsorship, and we look forward to hearing what some of their key executives have to say. And of course, that forecast I've just mentioned to you is really just about the Australian energy market, the national electricity market. There are even bigger plans to have huge solar resources in the Northern Territory and the West Australia, looking at export opportunities, be that by cable or by this newly emerging hydrogen industry. And I just think that the opportunities for solar is just quite extraordinary. And so I hope that we can tease more about that over the next 45 minutes. So without further ado, I'm actually going to introduce you to our first speaker for the day. It's Mark Legg. He is the Key Account Director for Longi Australia. He joined Longi Australia as a Key Account Director in February 2020. He's part of one of the growing team for Longi in Australia. His focus on sales and development in the utility and project segments, and he brings rich experience in PV, having worked in the distribution, commercial, industrial and utility sectors in Australia, New Zealand and Oceania. So without further ado, thanks once again for joining us. Mark, you have the floor.
Thanks, Giles. Much appreciated. So as Giles mentioned, I'll be talking specifically around the large scale and why it's important to embrace new technology for developers. So what we're doing, the reasons for solar farms, really there are the economic and non-economic factors. Obviously, we're all in business. We want to make money for our stakeholders, for the company, and we also have the added benefits of being in the green sector of the market, where we want to reduce pollution. It's also creating the jobs, local and otherwise, and increase land biodiversity value. So how do we become a profitable enterprise? And that's obviously some of the challenges that are being faced in the market at the moment. We've all seen what's happening with some of the EPCs, that we've encountered some problems along the way. But in order to be profitable, we need to sell the electricity. So how do we do that? Obviously, it comes down to the building your solar farm or your asset effectively. You want to maximise the output of the farm. You want a farm or a project that is going to last a long time. You want to get your 25, 30, 35 years. You want that asset to be running and profitable as long as physically possible. And also, where possible, sometimes the footprint or the amount of area available to an asset owner is extremely important. So why, again, we're talking about the maximising the efficiency. We want to reduce the footprint, and so that's again one of the challenges we're facing with the new technology coming out, the higher output, the higher performing modules. So that is a way for us to embrace reducing the footprint of our asset. So again, coming back to being profitable, how do you reduce your costs? Obviously, on a large scale already, any farm or project, you have your project costs. Labour is a large component of that, your BOS, and again, any land constraints. Sometimes a developer will have clauses where if they don't utilise or need any of the land that they've got as part of their project, they can save money. So again, coming back to why we can maximise the efficiency or the output and get as much bang for your buck for your asset. When it comes to innovation within the technology of solar modules over the years, you've got or had a wide variety of choices available. The obviously poly versus mono. What we're seeing now into the market becoming quite commonplace is a half cell module, and the big one is bifacial. So a lot of customers are looking at that and trying to work out, is that a decision that we want to take? Obviously, there's additional capex required on a bifacial because of the technology involved, and one of the key questions is getting the bankability around a bifacial. So a lot of study, a lot of research is required, very site specific when you're talking about a bifacial farm, whether the conditions, the albedo will be such that it allows you to gain the maximum uptake from that. So there's definitely the market is embracing bifacial. We've had a couple of bifacial farms in Australia, and I think we'll be seeing more and more of those. Expectations are globally that bifacial will probably be about 50% of the modules sold by 2021 or 2022. So there's some, and obviously as the module technologies and as more and more bifacial modules are used and utilised, and we get real world results backing up the research and the testing done through lab conditions and factory testing, we'll see more of those rolled out, because there's a significant advantage if your site does have those conditions that warrant it. Yeah, very much a good decision to make if it's suitable. Again, a couple of other technologies: heterojunction, IBC, PERC and PERT. I'm not going to go into all of these. Another one that's coming up more prevalently is the P-type versus N-type. Which of those? And again, another cost-effective decision is to whether to embrace and move into that type of technology. Probably not so much in the C&I or the project is the thin film, whether that's something that's a little bit more of a BIP fee solution for the residential side of the market. So what we're faced with today, if you're an asset owner, developer, EPC, is what's the decision that you're going to make for your project. The poly market is still there, but I think everybody would agree that the dwindling supply around manufacturers that are still doing poly, it's not as cost effective as it used to be. Go back a couple of years and you could see a 30% increase if you wanted to take a jump from a poly product to a mono. The last sort of 12 to 18 months, a significant decrease in the cost of monosilicon, monocrystalline cells and wafers has brought that price differential very, very close. So when looking at a farm, I think most products or assets now will be using mono, and then we're left with the variations, if you will, across from that. So half cell, again, quite prevalent. Most of the major manufacturers have embraced this technology, anywhere from a 5 to 10% increase versus a full cell like-for-like product. And again, bifacial is becoming increasingly popular. From a local perspective, what Longi's done in Australia, 6 projects completed: Numurkah, Beryl, Rugby Run, Chichester, Kahuna and Gangary, and we should be adding to that list fairly soon, but those projects are in various stages, either have achieved COD or in construction at the moment. What I'd like to talk about specifically with Longi, we've added to the team here in Australia over almost sort of 500 megawatts of local projects here. And what we're hoping to do is partner with companies that are looking for that local feet on the ground, someone answering the phone and not dealing with an international time difference. So from our perspective, we've got the office here in Sydney, a couple of guys in the project team, and we're here to support the product. We're here to support our customers, here to support our partners in the industry. So very much a localised support. Here is a very nice picture of the Numurkah solar farm, very pretty and nice and lush and green as well. So talking about the warranty, obviously, you know, whenever a customer developer is looking for a choice, what you need to consider is the company that you're going to be working with, whether that's a module, whether that's a inverter tracker, any BOS component. One of the considerations is, do they have an Australian office? Not to say that if they don't, it's something that you will choose not to, but I definitely think that having a local office, someone that you can meet on a regular basis and discuss any aspects of your requirements, and you want a product that's going to stand the test of time. So of those 6 projects, we haven't had any warranty claims that are based around performance. A couple of breakages through transport, those things are going to happen from time to time, but it's I think what most people would agree is that you want to be able to have a product that's supported, and things do. It's a manufactured problem, manufactured product. So when issues do occur, as they do from time to time, you want to be able to get in contact with someone. Having a length of warranty term that is benefits your project. Most manufacturers are increasing their product warranty, but obviously want to get that performance warranty at the 25 for a monofacial or a 30-year for a bifacial project. As I said, on those projects, we've had very few number of claims, none of them around performance. And that adds to our bankability of our project, of our product. So Longi's been rated the AAA rating through PV Tech, which just stands to the fact that globally we're doing the right thing. We're putting a product out in the market that is going to stand the test of time, which should give you a level of comfort that if you choose Longi, then you're making a right decision. You've got a product that's going to stand the test of time. It's going to be bankable. It's going to be reliable. And it's one of those things that you just want to essentially build a product and hopefully forget about it other than a few OEM requirements. Again, this is the bankability I was just referring to. You want to have lenders that are going to finance the project. So most of the lenders in Australia are very familiar with solar as a bankable and a sector of the market they need to look very closely at, and most of them have their people in there that are very much aware of the situation of how to make a product profitable. So I don't think there's the difficulties that there were a few years ago. Again, Longi scored very high on that, on the Altman Z top and the AAA rating, which is on the pyramid there. I'll let Richard talk a little bit more about the technology. We're going to have close to 10 gigawatts of production at the end of this year on our new technology. We are releasing a HIMO 5 product that will be released to have a global launch next month. Won't talk too much about the innovations, but yes, we also are a very sustainable company, so doing the right thing for the environment. And that is all from me, so back to you, Giles.
Thanks very much, Mark, and thank you very much for that information. Interesting to see the number of solar projects still underway, and quite reassuring that the market is still ticking along. Next speaker is Richard Chan. He's going to be talking about the trends in module technology and development. And Richard is the product manager at Longi Australia. He holds a Master of Photovoltaic and Renewable Energy from the University of New South Wales and has more than 8 years experience in the solar industry. Prior to joining Longi, he worked at TVV Rhineland, where he was in charge of solar module certification and testing, and he has consultancy experience in providing quality assurance services and was technical lead at SolarJuice. He supports Australian customers with his responsibility for all technical matters on Longi's products. Richard, over to you. Thanks very much.
Thanks, Joe. Happy to be here today. Just a few seconds. Let me just. Right. So I'll just take a few minutes to talk about the trends of solar module products in recent years and how Longi has been leading that trend. So just a few years back, in around 2013, I was responsible for calibrating solar modules in the lab of TÜV Rheinland, and I clearly remember that the 300-watt 72-cell poly module was predominantly led the market and was using most of the large-scale ground mount projects. And it took nearly 6 years for the power of module of similar application to be raised from 300 to 400 watt. And surprisingly, it takes only 1 year. And now in 2020, that we are talking about modules of more than 500 watt of power. So what really happened? There are a couple of factors that has driven such involvement. First of all is the competitiveness of monocrystalline silicon technology and its growing market share. Since Longi started its module business back in 2015, we have set a tone that high efficiency mono product is the future of solar industry. we've been dedicated to monocrystalline silicon because there was so much to explore in terms of efficiency and cost. Also, the commercialization of the PERC technology became the catalyst of such development. It brings down the cost even more due to the increasing efficiency and the massive volume, which makes mono modules progressively cost effective. As for the efficiency, in order to continuously optimize our mono wafer cell and module products, LONGi has invested a huge amount of resources into R&D, which accounts for around 5 to 6% of revenue each year. LONGi has achieved a world record of 24.06% cell efficiency in 2019, and we will continuously push the limit on both R&D line and mass production. On a module level, we've also explored options to minimize cell to module losses and try to have the module output as high as possible. For example, like half-cut cell or multi-bus bar and so on. These technologies basically reduce internal resistance loss, lower operating temperature, and captures more light. Among all the innovations, and the increasing of wafer size seems to be the most straightforward and effective approach of increasing module power and reducing cost. So 10 years ago, monosilicon wafer was classified as a size of 125 by 125 millimeter, and so-called a 5-inch size. And at that time, the 72 cell module power output is around 190, 200 watt. And a few years later, LONGi, with other major wafer suppliers, set the M2 standard, which is 156.75 mil by length. And LONGi's first 3 generation of module products are all based on this size.
Richard, can I just, sorry to interrupt here in the middle of your presentation, but I'm just wondering if you're hoping to share some slides. I'm not too sure whether you're up to there yet, but we can't see them. So you might have to put the share screen. Are you trying to share the slides?
Yes, I'm actually, let me just have a check.
Sorry, listeners, we'll just sort of just pause for 30 seconds while we just sort this out. We had a couple of people saying, we need to, we can't see the slides. So I don't know whether Mark's next to you. He managed to share his slides. So I think it's the share screen. Perhaps Max can intervene if he's there. Aha, excellent. Back to you, Richard.
Sorry, guys. Apologies for that. So I think I was here, yeah. So back to the wafer size. Yes, the M2 wafer became increasingly popular and has dominated the market for a couple of years. And since 2014, we've seen other wafer dimensions coming up on the market. But LONGi decided to take a different approach. In 2019 May, LONGi launched the HIMO 4 series based on M6 wafer, which became another industry standard. And in conjunction with other technologies, the module power output can reach 450 right now, which is available to our customer. And in a few days, we'll also witness the release of the LONGi's 2020 new product HIMO 5, which is based on an even bigger wafer. And the power class may reach 535 watt, and with an efficiency maybe more than 21%. This is not only the result of LONGi's years of efforts in R&D, but also driven by customer and market demand, which is pursuing a lower BOS cost and better So solar PV has become more competitive as a energy source in terms of overall spending per watt peak. If we look at the cost breakdown here of the utility scale solar in Australia, the contribution of solar module is getting less significant, especially in market like Australia, where BOS and other soft costs take up more proportion. As a module supplier, the value that LONGi can bring to a customer is to lower the system cost even further as a result of using our already cost-effective product. So therefore, increasing the power of individual module is one of the most effective ways to achieve that. So let's take a quick example of a typical 120 megawatt projects in New South Wales, for example. When using a 450 watt high mode 4 instead of a 410 watt module, more than 26,000 modules can be saved from purchasing, logistics, installation, inspection, etc. That also leads to roughly 900 less strain numbers and trackers. This reminds me of a chat with a customer last year, and the gentleman said to me that you really need to create a higher power module, like 500, even 600, because he's got a ambitious plan of a 1 gigawatt project, but the fact that the millions of stainless steel cable clips cost him too much, and it's quite hard to procure. I thought it's impossible at that time, in short run at least, but look where we are now. So basically, our customer aims to have either maximum DC capacity within a limited area of land, or have more flexibility on design and deployment with fewer modules and strings. And high power module is the best option to realize either scenarios. In order to further lower the LCOE, to maximize the lifetime yield is also critical. That will relate to multiple factors, for example, the module's longevity, reliability, low light performance, low degradation, and a bit of extra bifacial gain. So the bifacial module is another key product in our portfolio. We've seen a shift to a bifacial module from more than 50% of our customers' project pipeline here in Australia. One of the main advantages of using high efficient and high power bifacial module is that with fewer modules and the strings being used, the system yield can basically benefit from larger row spacing because more light can be absorbed from the backside, which in turn improves the LCOE. LONGi started shipping bifacial module in 2017 and has so far delivered more than 5 gigawatt of bifacial module, which makes us the top one in the world. Therefore, we have extensive experience and comprehensive data from projects around the globe. LONGi is also one of the first and few suppliers that guarantees industry-leading low LID and degradation in P-type PERC model, which is also critical to ensure higher lifetime yield and lower LCOE. So in our standard performance warranty, 2% for the first year and 0.45% from year 2 is guaranteed. However, from real project data, we've observed that roughly 0.3%, 0.4% annual degradation can be achieved. So Mark just touched a little bit on quality and reliability, which is another critical factor. High quality and reliable modules reduce the chance of system downtime, therefore minimize operating expenditures and ensures constant output. Just a few days ago, we've achieved one of the top performers in the PVEL 2020 reliability scorecard. And you can see that we've also achieved the PV Module Index High Achiever from ITC in 2019, and also ranked the first in two-for-island PV module power generation simulation. So lastly, I would like to say that using high power module to achieve a high financial return has become the consensus in the solar industry. But increasing size is not unlimited. It must have a boundary. So let's look forward to the HIMO 5 launch in just a few days, and yeah, stay tuned. Thank you, guys. That's all from me. Back to you, Joe.
Thanks very much, Richard. And it's probably a good time to point out some recent research that has been just published by the International Renewable Energy Agency. And we published a story today pointing out and just reminding us that the cost of solar modules and the levelized cost of electricity from solar has actually come down 80% over the last 9 years, from 2010 for 2019. And that's from completed projects. And what I found really interesting about that research report was the forecast that they would fall another 40% just from the projects which have kind of been bid just in the last couple of years and which will be completed over the next couple of years. And I guess that goes some way to pointing to what Richard was talking about, was the big increase in from 300 watts. It took forever to get to 400 watts and then a very quick jump up to the next level. So obviously we're just seeing some major gains in technology advances, and I guess one of the interesting questions at the end of this will be how much more we can possibly get in. And we've already got a few questions about bifacial technology, so you can look forward to those, Richard. But look, our final speaker today is David Owen. David is he's going to speak about data and information from the most recent PV module tech bankability report. David is the founder and director at Solar Media Limited. He's the publisher of PVTech.org, Energy Storage News, and Photovoltaics International. And David's been with the solar industry for about 15 years. He's consulted with various government bodies, large multinational solar companies and developers from Australia and around the world. And he is about to reveal some of that data and information from the latest PV module tech bankability report. And I will leave the floor to David. David, welcome. Thanks for joining us.
Thanks, Charles. Thanks for having me. Let me just share my screen here. There we are. Hi, everybody. Welcome, and thanks very much, Renew Economy, for hosting this important topic. I think it's quite timely. There's quite a lot going on in the sector right now, and there's an awful lot happening in terms of deployment. Even despite what's happening in terms of COVID-19 and the imminent lockdowns that many countries are finding themselves in. Those of you who don't know us, some of you would be familiar with PV Tech, which is our news site. We actually have a research arm, which we started about 5 years ago. We've been collecting data for over a decade across the entire PV module and other ancillary area supply chains, including energy storage and EVs and other areas related to the clean energy transition. Our PV manufacturing technology report, that's been going formally now for 4 years, and it tracks the supply chains of all of the capital equipment and all of the supply chains that go into the module manufacturers like Longi Solar and Jinko and other module manufacturers and cell producers that you'd be familiar with. That's very much an upstream report. So it really looks at all those different opportunities for technology improvement. So I'll talk a little bit about some of the trends that we've seen, that we're tracking, and some of the future trends. Our second report from amongst our stable that I wanted to go through today, based on the topic we've got, is just to give you a bit of an insight into what the bankability ratings are. We launched them publicly last year from some demand from the industry, particularly developers and sophisticated funders who are doing multinational projects. They're working across different borders, and they needed to understand how to, I guess, shorten their lists for companies they were going to get modules from, to understand reliability and future financial performance. And that's quite difficult because there's so much competing information in the marketplace, some of it not reliable. And so it's really important that organizations can try and get an understanding for where products are going to be in the future, not just now. So I'm going to look a little bit about the history. I won't go into every single technology. We're just going to cover a couple of trends, and we've got a good chance for discussion later on to answer any questions. If you are interested in the report, the link's there, and I'm sure the slides will be available later, or you can email me. My email's down the bottom of the screen on the right-hand side. So there we go. Sorry. So first slide. Everyone's probably familiar with the supply chain of a solar module, but very briefly, obviously we start with our base material, which is silicon. We turn that into a crystallized form and we put it into wafers, and then we put those wafers into various manufacturing techniques to create a cell architecture to create our cells. So when people are talking about P-type or N-type or mono or multi, what they're usually talking about is the wafer and the cell. So you have to do certain things to the wafer when you create it in order for it to be a mono or a multi wafer, which then gets operated on. Let's say there's lots of different techniques you can use to depose onto these wafers to create your cells. And so we won't go into every single one of them, but certainly the mainstream one, and Richard touched on this in his presentation before, has now emerged to be P-type mono. So if you look at this graph here, this goes back to 2018. If we went back 3 years ago and looked at our data, you would see that P-type multi, monofacial P-type multi, there was no bifacial back in 2016, was almost 80% of the crystalline silicon market for cells. That has changed dramatically from 2018 onwards, which is why I've started this graph from 2018. So almost 48% of the market in 2018 transitioned into a P-type mono process for the cell production. And you've seen that grow last year, and it's increased this year. By the end of this year, we'll see almost 85% of all cell production in the solar industry moving to P-type mono, which is just a huge step change. And it's happening very, very rapidly. And it's something that we'll talk about, which is the adoption, the more rapid rate of technology adoption now compared to what it was 10 years ago. And this is creating all sorts of issues for projects, and particularly for larger developers and distributors who need to understand the supply chain. Just, it's worth noting, seeing as we are here in a panel with Longi, that Longi has been one of the key drivers to pushing the entire industry to P-type mono. They did a big bet on that a number of years ago, and they've continued to ramp up their production over those years and have really driven the cost down for everybody. So we have a lot to thank Longi for. The next trend, I noticed it on Richard's slide, and I know there's a lot of talk about it, and that's N-type. So N-type is one of the next technology nodes that the industry is working towards. I think this is really pertinent at the moment because it does highlight my main point, which is that we're seeing trends technology accelerate dramatically, and N-type is a really good example of that. So there's a lot of talk about it, but right now we're seeing between 500 megawatts and a gigawatt of capacity for N-type currently in the market. Now, to put that in perspective to the previous slide, you're looking at almost 80% of the market being P-type mono next year. So half a gig to a gig is actually not very much. So this is what we call pilot lines, and it will take at least 2 to 3 years, up to 2022, before we would see any significant ramp of N-type cell production. And that's a key limiting factor when you're looking at new technology types going forward. So yes, you might be able to source some of these products. There are some available in the market now, and so you can use them, but they're going to be used in relatively small numbers and smaller applications. When we look at our bankability rating, just got a couple of slides here, which I'll gloss over, and I can go into more detail if there are questions on them. But when we try to analyze what we're doing in terms of bankability to understand, is a module bankable? Is a module company bankable? We look at a number of key things. So this is the methodology that we use. So our bankability score is made up of financial scores and a number of manufacturing scores. And the manufacturing scores are really what set it apart from other types of ratings that you may have come across in the solar industry. And they're really important because financial scores are, let's say, I wouldn't say they're easy to game, but they can differ depending on whether an organisation is a publicly traded organisation or a privately held company. And so getting financial information that's accurate and timely and reliable can be quite difficult. So we compare that with data that we've been tracking for the past decade, looking at their supply chain, their capacity, their technology, and how quickly they are able to ramp new technology. And that's a really important input when you're looking at the viability of a module company from a longer term supply chain arrangement. So just to go back here for an example, this is the table of contents of the most recent report. So we go through all of the major module companies in the world. And we also flag risk factors for each company. So we look at their financial and manufacturing trends and metrics that could impact on suppliers short-term or listings for large-scale utility projects. So the module tech bankability ratings are really important if you are a utility scale developer, funder, EPC, to understand where these products are going to be over the next 18 months. This is how we rate them. It's pretty self-explanatory. We follow similarly to some other popular rating agencies, just to give it a bit of ease of use when you're looking at what's happening. And here is the most recent results. So this is updated daily, but we released information to report holders quarterly. So you can see that the highest rating is a AAA rating. As Longy pointed out on their slides earlier, they are currently the only company listed on at the top bar. However, there are many other companies that are very close to that, and it is our sincere hope that part of this bankability report, which is now, like I said, it's been researched for the past 3 years with data going back a decade, but it's only been publicly available since midway through 2019. And what we've seen is a trend of organisations within this pyramid who are coming to us or looking at the report in detail to try and understand what elements of their own business model can be adapted to help give confidence to their customers and the rest of the market. Again, realizing that we're here with Longy, I thought I'd just pull out a couple of slides from the most recent report, just to give you a feel for the type of information and the comparisons that we do. I've obviously blinded the other suppliers there, but here's some of the health scores, and there are a number of health scores. We don't just issue that big pyramid you saw. We look at all of those particular elements, the manufacturing, the finance, technology, and we rate across all of them. And there is detailed analytical information there as well. So here you've got the financial health score. Longy Solar appears quite well there. And the important point to make about Longy's financial health compared to other module manufacturers is, unlike many others, they are an integrated supply chain in their own right. So what I mean by that is they make the wafers, they're making the cells, and they're making the modules. Why is that important? Well, it gives them the ability to absorb short-term pricing shocks throughout the supply chain. So if there happens to be an oversupply of modules at the end of the year, they're not reliant exclusively on their module sales to generate cash flow for the business. That's really important from a long-term financial health perspective. So we believe that the sweet spot for an organization in terms of their module sales as a percentage of their overall revenue sits around that 30 to 60% of revenue. There are a number of companies that do fit within that band. It's not only Longy, but Longy does sit there, and and the big reason is they've got a very, very strong mono wafer business. And that's really important because it generates that revenue all through the supply chain. I'm not going to go through any more data there. I've got a couple of slides here I'll just briefly touch on, and then if there's anything we want to talk about in the discussion afterwards, it's probably worth going into. But my main point here is that technological change is accelerating. So new manufacturing tech, it used to be very slow to be adopted. There's a lot of talk about PERC. It was developed in the late 1980s by Martin Green and his team at the University of New South Wales. As you saw on my slide earlier, we didn't see mass production of PERC technologies until 2016, 2017, deployment 2017, 2018. Now we're all talking about it as the majority technology in the market, and indeed it is, of course, but it's taken almost 25 years to get to that point. What we're now seeing though is new module tech is those adoption rates are going to continue to accelerate as the market matures. And that's driven by more sophisticated and larger supply chains. It's driven by money financially, because you've got really big funders who are in the market now, who are trying to understand how to squeeze better yields out of their projects, trying to understand what type of technology they're going to be using in 18 months' time within their project life cycle. And so they've put a lot stronger, a much larger demand. Richard gave that little case study I thought was quite interesting. Well, not a case study, but when he spoke about his customer asking about, we want a 500-watt module because our clamps are too expensive. And as he said, last year, they asked him and he said he couldn't believe that he might be able to supply something like that this year. And what we're seeing is some of these really big developers are actually getting almost bespoke modules produced for them. Because if you've got a gigawatt project, you're talking about taking up a factory's output for the better part of half a year, if it's a really large factory, or even a full year, if it's an average size factory. So you can almost stipulate all the materials that you want into your module. You can stipulate the size, you can stipulate the cells, and so you can almost create a bespoke product for very large projects. So that's driving this technology adoption. And just to finish off on, why does this matter for you? Well, I've mentioned this a few times, but it really is important that you have some kind of technical help to decipher the best modules, because those modules will change based on the year. You might see 2 or 3 launches from companies just within 1 year. 5 years ago, they might launch 1 new module every 3 years with a different technology. Okay, so it's really important to understand, what do they mean for your business? Form factor might be an issue, power density is a massive issue. And one of the biggest issues, if you talk to the CEC and Sandy Pulsford and what's happening in terms of accreditation, is the bill of materials. We haven't even scratched that topic, but it really is an area that's quite difficult to manage. Just finally, just to mention, check out the PVAL and DNVGL reliability scorecard. It's great, it's free. Go to that link. We're completely non-affiliated. We did do an analysis of it, which is quite in-depth and detailed. You can check that out. And of course, if you are interested in any of our market research, please do get in touch with us and be happy to answer questions. So I'll throw back to you, Giles, and thanks very much for your time.
Thank you very much, David. Look, fascinating report. And look, it's question time now. We've got David as well as Mark and Richard from Longi Solar online to answer some questions. Now, look, some of them, we've got a bunch of questions here. Some of them are a bit technical. So the suggestion is that we might actually do an FAQ and publish that along when we publish the webinar and go into some of the details of them, because some of the ones are really, really technical. For instance, on bifacial panels. But one quick one for you, David. Someone's just asking about your market reports. How much are they, and how much do they cost to obtain? I'm presuming some of it's free, but some of it does cost some money.
Yeah, it does. To get the quarterly report, they're all different prices basically, but the bankability report, it varies on the size of your organization and what you want to use it for. So I'm not going to give you a direct price online, but it is in the thousands. It's not a free report by any means. It's very detailed, and we have a team of 6 analysts who their entire full-time job is updating our reports. So get in touch via the link or send me an email, and happy to take that offline.
Fantastic. Okay, thanks for that. We've had a couple of questions about, will the presentation slides be available? And yes, they will be when we post the webinar up on the website, and you'll be able to listen to it and see those slides again. Richard and Mark, I think we might go into a couple of bifacial questions. Now, there's one question here, which is, do you consider bifacial solar modules as thoroughly proven technology? And I guess the answer to that is probably yes, given how much is actually being built. But another part of that question is, how long are the completed projects up and running? So when were the first bifacial projects delivered, I guess, is the question. Richard or Mark?
As I mentioned in my presentation, we started to deliver bifacial module in 2017, and the volume that we have delivered globally has exceeded 5 gigawatts. So it's a proven technology from our perspective. Absolutely. Yeah.
There you go. And another question here is, has any research been done on combining bifacials with cool roof technology on C&I projects? And look, I'm actually not too sure if I know what cool roof technology is, but maybe you guys have an idea.
I'm not sure about that one. Maybe there is something going on in our R&D department, but maybe that's something that we can explore.
Sure. Yeah. And look, one other question for you, Richard, was I was just fascinated by that IRENA report and the cost reductions and what you were saying about how the the output of the panels has grown so quickly. And I guess the assumption was that the cost of solar technology in general will continue to fall, but maybe it might be maxing out and the reductions will actually be smaller over time.
Mm-hmm.
I'm just wondering, given the light of, in the light of the IRENA report, which seems to be talking almost like accelerated cost reductions, and given the sort of the major, improvements in technology, I mean, do we get to a point where the improvements are maxed out and then become only marginal, or are we still possible? I mean, how much output can we possibly fit onto a panel? Could we get to one day? Could it be 600 or 700? I mean, is there a maximum? Is there a physical limit to this, or? Yes.
Well, I think there's definitely a physical limit especially for the size of the module. I think what we have got here. For example, when we talk about the boundary, we talk about for example, transportation limit of the module. If it's too big, then it won't fit into the container. That sorts of thing. With the efficiency increasing yearly, we can see that. There might be sometimes in a few years there might be new technology coming up. For example, the N-type, when it becomes like cost effective, that would catch up the volume, like the P-type technology.
Mm-hmm. There's another question here about perovskite. I'm not too sure, that's not something that you've mentioned. I'm not too sure whether you're sort of dialing that into your sort of future module designs, but is that something that sort of, or is that more for your R&D folk back in LONGi headquarters?
I think our R&D is have different options. They're exploring different options in their pipelines. I'm not sure perovskite is one of the solutions, but definitely we will look into that. Okay, excellent.
Okay, there's a couple of other little bifacial questions which are really technical. I think we'll just put that onto FAQs.
Mm-hmm.
David, one for you. You mentioned you had in your report, there's a bit of a question about thin film, and that's not really the subject of this LONGi webinar, because I don't think LONGi does thin film, but it was interesting just to note that the market share never really grew. What happened there?
Okay, I mean, thin film was it only became popular because silicon was so expensive, essentially, and so back in the 2000s, silicon became much cheaper, and so the business case for most thin film technologies just fell apart. First Solar had their own projects, so they've been able to keep going. I see the question on First Solar; they're still there, they're still kicking on, but it's not a primary part of the market. We don't see their market share growing much beyond where it is, which is less than 5% right now. Just quickly on the bifacial point too, you talked about reliability there. Some of the first bifacial projects have now been in the field for 4 or 5 years, but only in the last 6 months, we've just started to see the very first case studies and direct scientific reports in terms of performance, and they're all coming back very positively. So in terms of tested and proven, I think bifacial is pretty clear that it's a winner, and we personally see probably 30 to 50% bifacial market share over the next few years being well and truly achievable, because one of the questions mentions rooftop applications for bifacial, and yeah, we're actually seeing some rooftop installations around the world where they are using not just cool roof but other types of racking systems and new ways to get light to the backside of a module. There's lots of technical improvements, not just at the module and cell level, but also in installation level, where we can see significant improvements. And Richard mentioned a few of those, with the ability to space out modules more, looking at the albedo and how that's done. But I guess the one thing that's holding back bifacial modules from sort of wide stream acclaim, if you want to say that, is that there aren't really the same standards in place for bifacial modules that are as well established in the monofacial side. So we all know what we're dealing with monofacial technology. Bifacial's still a bit new from that standpoint, but so far it hasn't affected adoption rates. So the people who are ordering it are very happy with what they've got.
Mark, here's a question for you. It's on the EPC construction. It's the question is, what common challenges have you seen with EPC construction in general on solar, and if any specific examples with bifacial, e.g. the clamping and the handling and the micro cracking and obtaining timely AEMO sign-off? That's probably a bit technical too, but do you want to have a bit of a general stab at it?
Probably the biggest challenge is logistically getting it through from the head office, the factories in China across to your specific site. Obviously, it's going to be handling the container, packed securely, but I think the biggest challenge there is just making sure, especially a double glass module, is making sure that it gets to site in the same condition that it left the factory. But in terms of handling, they do weigh a little bit more, obviously, with a double glass format. So again, manual handling on site, it's a two-person lift, so you do have to be extremely careful and, you know, adhere to the specific clamping zones that come with the installation manual. Micro cracking, again, if the transport and you know, the distance is travelled and it's being handled correctly, you shouldn't experience any micro cracking. The glass is designed to support, obviously, being in transit and to be out, you know, getting hailstorms and things like that, and exposed to the weather conditions that Australia has, which is, you know, quite frankly, pretty harsh. I think the biggest micro cracking is mishandling, or if you're looking at sort of CNI applications, is vandalism. You know, had one or two queries back in my past life on you know, people actually standing and installers, you know, walking on modules themselves, which is doing, you know, more damage than probably a you know, installation team doing things in the correct way. So as for an AEMO sign-off, I haven't seen anything differentiated between a bifacial or a monofacial, unfortunately.
Okay. Look, but we're getting towards the end of the hour here. We might have just one more question, and this is about product availability 15 years down the track, and he's talking about linking this with changing technology. And I guess they're worried about whether they can get like-for-like modules in replacement down there. I'm not too sure that's the specific answer to the question, because certainly in 15 years' time you'll be able to replace your module somehow, and I presume you'll be able to replace your modules with Longi. Richard, possibly an opportunity to talk about Longi's presence in Australia, because you've recently expanded and you've actually got quite a sizable team in Australia, and I guess that sort of points to your you know, your commitment to the Australian market. But maybe you could also sort of answer that that question at the same time.
Yes, absolutely. We now got like 12 employees in our office based in Sydney, and we've got a warehouse around all 5 states. So just be ready to dispatch any modules to our customer. And in terms of the 15-year replacement, I think for a ground mount or that large-scale solar projects, there will be some spare modules ready to be replaced on site, and we're pretty confident that these spare modules will be low enough to just in case some panels got some trouble. But just in case, I mean, the site is running out of spares, and I think in 15 years, I think the better way is to get a maybe new product, which is more cost effective in 15 years, I think.
Especially for a residential application, as Richard said, if it's a large commercial or a utility project, there'd be adequate spares that were included in the contract that will be kept there for those purposes that we hopefully won't be used and will be sitting there gathering dust. If a residential you know, system got to the 15-year mark, which everyone hopes it does, and you had a problem at that time, more than likely I'd say that there's going to be a problem with the inverter. But at that time, if you got a good 15 years without having a problem, it would probably be more economic, especially with the way that the cost of solar through the market is decreasing, that in 15 years' time it would probably be a viable option to increase the system, as most of your components would be considerably outdated as to what would be available at that time.
Yeah. Okay, thank you. Look, we've actually come to the end of our hour, so it's probably time to wrap up here. There are a few other questions, particularly on recycling modules and some of the environmental issues, and we'll address that with our FAQs, which we'll post onto the website, and also about opportunities for local manufacturing in Australia. Would love to ask those questions now, but we are running out of time. Look, I'd just like to thank everyone for joining this webinar. I'd like to thank Longi for sponsoring it and participating in it, and it was great to have you on board. I'd like to thank David and all the people who helped with the production of the webinar and making sure it came to pass and it went well, including Max and Anne and all the designers. Once again, you will be able to find this webinar on your website. You'll be able to find all the questions. You will be able to find the presentations, and we look forward to welcoming you back the next time we host a webinar, which we hope will be sometime soon. Bye for now. Thanks for joining us. Thanks to Longi Solar, and have a good day.